Many people over the course of time have had a great impact on astronomy. Your goal today is to be able to describe the basic development of astronomy and how culture impacted its development. This monument probably looks pretty familiar to you. This is Stonehenge, which was constructed somewhere around 3000 to possibly 1800 BC. It was believed to be constructed as a calendar, and you can see, according to this picture here on the right, you can see some lines that are showing things like. Here's another example. This one is from the Native Americans in Wyoming. This is called the Bighorn Medicine Wheel. And if you look at these lines, the blue and red ones, the red lines represent the summer solstice, sunrise and sunset, and then the blue one represents the cirrus rise. This is just another example of astronomical observation. The ancient Greeks, their models were generally wrong because they were based on wrong first principles and believed to be obvious and not questioned. So they came up with these original ideas, and those ideas were not to be questioned no matter what, which prevented them from really understanding. The ancient Greeks had two main beliefs. The first was that the universe was geocentric, which means revolves around the earth. So the earth was at the center of the universe. The second was that the heavens were perfect. So motions of all celestial bodies were described by motions involving objects with perfect shapes or spheres. Astronomers at the time believed that the universe was geocentric, so they needed a way to describe the observance that the planets were going backwards in the sky, because if it was geocentric, that would not be the case. So they needed something new, and that's where so late in the 1400s, along came Copernicus, who disagreed with the geocentric theory and presented the heliocentric theory that the universe was centered around the sun. Retrograde motion is that Mars appears to move backwards in the sky. However, the Earth is really passing Mars because Mars has a longer year than Earth. Galileo focused on evidence to support his claims. So here you see what the ellipses of Venus would look like, but here is what it really is. You see a full eclipse of Venus. And along came Galileo, who invented the modern view of science, who transitioned it from faith-based science to observation-based science, and greatly improved the telescope, but he was not actually the inventor. The last thing he did was he meticulously reported the telescope observations that he had made. The Catholic Church disagreed with Galileo and opposed him and jailed him because he was speaking and writing against the views of the church, and he was sentenced to life in prison, which was altered to life in house arrest, which continued until his death. Along come two more astronomers. One was Tycho Brahe, and the second was Johannes Kepler. Tycho Brahe focused on collecting observational data with telescopes and created very detailed tables, while Johannes Kepler used those tables to study planetary motion mathematically and come up with his laws. Kepler had three laws. The first of his laws was that the orbits of the planets are ellipses with the sun at one focus, and not a complete circle. The second was that a line from the planet to the sun sweeps over equal areas in equal intervals. I think it's always kind of interesting to look at scientists in perspective to what was going on in history. Here we can see Copernicus lived at the same time as Martin Luther in the religious revolution. Then you see Galileo, Brahe, and Kepler all lived about the same time, followed by Isaac Newton about 100 years later, followed by the American Revolution. That concludes this presentation. At this time, if you would go to the discussion questions on Schoology and post, please. Thank you.
Created using Powtoon.